Thank you. How many people here play with hardware, Arduinos, or well, that sort of explains why you're here. Anyone done Raspberry Pi stuff? Right? Cool. Okay. So I'm going to be talking about CircuitPython, which is a version of Python running on hardware. And let's just go in. A little bit about me, mostly because some of it's relevant. I started off back in the 80s when you had 40-pin chips that were 8 bits and ran at 1 megahertz. So we'll see things are a bit different now. But I started off with hardware doing assembly language, switched over to software only, and spent years and years and decades doing all kinds of software in all kinds of domains with all kinds of languages. Never Python. By the time I ran into Python, I had been doing a lot of Ruby and figured, well, you know, what's the advantage? And I had some bad initial experiences. So even when I was at Google, I fought using Python, even when they sent me for Python re-education classes and so forth. And I know Guido, he and I have run into each other a few times over the years, but I never got into it. About 6 years ago, I ended up at any gamers in here? Video gamers? You know, SteelSeries? Anyone know SteelSeries? I ended up working there as their lead engineer and got back into hardware and realized that I love it, right? What was I doing for the last 25 years? It wasn't hardware. I was working in C++ primarily, and eventually I was buying parts and stuff from Adafruit, and then they had this CircuitPython thing, and that caught my interest. And though I'm still learning Python and discovering about it, but it's probably the major language I use these days. And if not that, probably C++. So, sort of full circle with extra stuff. So, one question I have is, where does your Python code run? Does it run somewhere like this in the cloud? Hands? Yeah, okay, web services, all that stuff. Maybe it runs here. Anyone write desktop apps in Python? Yeah. Okay. Maybe even it runs on something like this, a Raspberry Pi. It's physically smaller, and memory and performance is smaller, but it's still a Linux machine. So it's really not that different than this or this, just a matter of scale. What about this? All right. So see the green light? That's one of these boards. We'll see that in a bit. And you can see how small that is from the fingers. It's a little over ½ an inch by a little less than an inch, I think. Anyway, so brings us to CircuitPython. It's a fork of MicroPython, which is a from-scratch implementation or re-implementation of CPython, specifically targeted at small hardware, low memory, low performance. And specifically, at least initially, it was for the ARM Cortex-M series of microcontrollers. So these are 32-bit. They run sort of tens of megahertz, right? So small, and usually have, you know, a few hundred K of flash and a few dozen K of RAM. So pretty small stuff. The microbit. Who's heard of the microbit? From the BBC. That runs MicroPython. Right. And there are others. There are ports all the time. So CircuitPython is a fork of MicroPython. Adafruit, who maintains and writes and whatnot, CircuitPython, was coming out with new boards that had the SAMD from Microchip Atmel, the SAMD series of MCUs, which are ARM Cortex-based. So they wanted to port MicroPython for that. And while they're at it, they did a few other things, such as making it really nice for beginners and really easy to work with compared to MicroPython. So it is, to my best understanding, Python 3.6-ish, right? Because it's not CPython 3.6. It's a total different implementation, but it tries to target about 3.6. You plug it into the USB port. All these boards have a micro USB connector, and you have a REPL running on the hardware. additionally, there's flash, right? It's a microcontroller, so there's flash. Some of the boards have external flash, so they have like 2 or 4 or 8 megabytes of flash. Those show up as a USB drive. So if you want to put code on it, you just drag and drop your .py files onto the USB drive, and they're there. And if you call them main.py or code.py, when the hardware resets and the runtime comes up, it'll load those and execute them automatically. And by default, it's in the mode where if any of the files on that drive change, it will restart the runtime. Which means you can do things like, okay, and we'll see this in a bit. You have your file on the microcontroller in that USB drive. Open your editor, load it in, make a change, save it, it restarts. Which is really, really quick cycle. You have full access to the hardware from Python, but in a way that the low-level details, like the MCU registers and the peripheral registers, are abstracted away. Right, so it makes it nice and easy to use, but you still get access to everything in a board portable way. So you have every board has a board module that's automatically there, and that lets you access what all your I/O pins are, by name. So even though it might vary based on the MCU or on the board design, if you say board.scl, that is your I2C clock pin. Adafruit makes a lot of hardware. They make a lot of sensors in little breakouts that are very easy for people to use. And they make libraries for all of their hardware in C++ and now in CircuitPython. So here's an example. And instead of just doing this, I'm going to switch down here to the code. This is code on here. And you can see it creates an I2C interface. It creates an interface object for that sensor on that I2C bus, and then starts polling it. Starts asking just sensor temperature, sensor relative humidity, and then outputting it. So you can see the live feed scrolling up at the bottom. And if I put my finger on the sensor, 23, humidity's gone, 27.8, 27.4, 27. There you go, we broke 28 degrees. See how nervous I am up here. Okay, now, so this is the code on the board. We can edit it. This is the Mu editor, by the way, which is pretty cool. It doesn't compare to Emacs, but for beginners, it's just enough of an editor, and it has this environment built in. So that's the serial port via USB talking to the board. So I made a change here. So now it's going to print out a tuple. So if I save, it restarts, and now it's outputting that. Right? Now, Mu has this nice feature where if you output a tuple of numbers, you can turn on the plotter and see it plot. So now if we do that, so it's nice and easy to ramp up, see what's going on, right? Let's go down here. This is our serial. So if you use Arduino, this is your serial window, basically. Except if I say Control C, I'm now in a REPL. This seems to be my go-to for checking a REPL is doing 2 plus 3. Right? And you can import modules, you can write code, enter code in, run it, everything you can do at a REPL. Right? So that's pretty cool. So that was CircuitPython. Now where can you run it? And that's where the hardware comes in. That's the board I have here, this little tiny thing. It's running 32-bit Cortex-M0 core at 48 megahertz, 256K of flash, 32K of RAM. It's a tiny board, so you only have 5 pins available to connect to, but you can do any of this stuff with them. Right? So it gives you a bunch of flexibility, not a lot at any one time. So this is really good for simple and really embedded controllers. Right? It has I2C, so that gives you access to pretty much any sensor that you want. So for little data collection devices, These would be good. This is a neat board. This is what first caught my attention. This is Circuit Playground Express. Again, it has the Atmel SAMD chip. It also has 2 megabytes of SPI flash. So for libraries, you can put all your libraries on there. Data files, because it also has a built-in speaker, so you can put audio files on there and play them, right, from Python. Same processor, so same performance, same memory. Has the external flash. It has these NeoPixels, these RGB LEDs around the outside. Motion temperature light sensors. There's a microphone. There's a speaker. There are 2 push buttons and a slide switch that are readable. Infrared receiver and transmitter. And these pads around the outside are neat. They'll take an M3 bolt, so you can bolt things onto it. You can solder onto them. They're solder pads. And they're big enough to put an alligator clip through. So like the microbit, you can use alligator clips to hook up stuff. These are intended for classrooms primarily. They're great educational toys. Right. If you've ever used the microbit and played with MakeCode from Microsoft, this is supported by MakeCode. So you can use a block, it's like Scratch. Right? You can use a Scratch-like environment to write your code that runs on this, or you can use CircuitPython. And this is the new one that is, well, this is a prototype. It's not listed yet. It'll be out probably within a couple of months. It's a big one. If anyone's played with Arduinos, this is an Arduino Mega footprint and connections. So this gives you 120 megahertz Cortex M4, which is still 32-bit, a lot faster, a lot more performant. Also, digital signal processing, floating point in hardware, crypto in hardware. Right. It has 1 megabyte of flash and 256K of RAM, which is pretty sizable. You can do some cool stuff on there. I was talking to a fellow before this in the hall about the idea of doing machine learning. So you've taught your net, and now you have the data for it. You could execute it on something of this size, probably. Right? 54 GPIO pins, lots of capabilities on them. You want to connect it to things. You have 8 SIRCOMs, which are serial communication peripherals, that can do SPI, I2C, or UART. So a lot of connectivity. There's 8 megs of external SPI flash for video, audio, data, like a neural net model. There's a camera port on it. You can hook a camera to it. So with the DSP and the camera port and the external flash, you could probably do some pretty nice video processing on this. And if you want to get down in the weeds, there's an SWD debug port, so you can hook up to it and use GDB to look at whatever. Like I said, it's the Mega footprint, so all that I/O, great for doing robotics or industrial control, right? In Python. So here's sort of a family shot. I use a Mega here because I don't have one of these new boards yet, but that's the size it would be relative. There's a Uno format, M4 based board, the Circuit Playground Express. There's a Trinket up there. There's a Gemma that's meant for wearables, which is fun. There's an Itsy Bitsy and a Feather. Both these models are M4s. This is smaller, it's claim to fame. It's got a bit more I/O connectivity. This one has a lithium-ion, lithium polymer battery port or connection on it with a built-in charger. So plug in USB, it charges the battery. That's really cool. None of the others do. So that's sort of the Feather's claim to fame. So I mentioned robotics. You're working in Python, you've got microcontroller board. What are microcontroller boards good for? Making robots. So there's an add-on board. It's called the Cricut, hence the mascot. That, there's a model that the Circuit Playground Express bolts to. There's a model that Feather plugs into. If you have microbit, there's a model for the microbit. And probably this week, next week, there's a Raspberry Pi version. Again, same library, hitting them all. So your Python code's the same in any case. and the same capabilities. So there's a closer version. You can see all the connectivity around the outside. You get 4 analog or digital servo connections, 2 motors, 4 high current outputs for things like solenoids, electromagnets, that sort of thing. 4 touch sensors, digital I/O pins, which are also analog input, NeoPixel driver, and an amplifier to connect a speaker to. So everything you need for a relatively capable robot. The final thing is the community. One thing about Python I was always envious of was they always were reputed to have a really awesome community. I see some laughs, I see some head nods. Anyway, compared to Rails anyway, maybe. So Adafruit, it really tries to be community-oriented and helping people. And that's why I don't work for them, I work with them, I guess you'd say. And that's one of the reasons, because they're trying to help people learn this stuff. And that's what I want to do now, too. So there's learn.adafruit.com, which have 1,600, 1,700 guides, project guides, tutorials, etc. And that's one of the things I spend most of my time doing is writing these. I get to make fun projects and then write about them. Discord, who's on Discord? Yeah. So we have a Discord server where everybody hangs out. So if you have a CircuitPython question, Discord's where to go. There's a CircuitPython room, the team hangs out there. It's pretty awesome. And we have forums, which I was surprised still exist. But I'm going to be doing stuff there too. So if people hang out there, you have questions, you can post them there. The goal is to get an answer to every question, every basic question. Yes, open source. So it's all on GitHub. Adafruit/CircuitPython is the runtime code base. And all the libraries are on there. The circuit board design files are on there. So if you're doing 3D modeling, there's models of most of the stuff for Fusion 360. So you can grab a part and build around it in Fusion 360. And that's it. Yeah. So questions?
Yeah, we have some time for questions. If you wouldn't mind speaking into the microphone for questions, then we can have them on the recording.
Mine's really straightforward. Just would you mind putting the link to the Discord up? Or where could we find it? Would there maybe be on the GitHub for Adafruit?
Good question. I don't know what the link is. Just
I would
Google
imagine you
for
don't
it.
have the link. Okay, sure.
Yeah, I don't have it offhand. Yeah, but yeah, it'll be on there somewhere. Search for Adafruit Discord. I think they got a guide on how to hook it up. Right. Okay. Oh.
You showed that really cool REPL. Does that interrupt the running program or not?
It does.
Okay.
Yeah. So
Hi. You said it was a fork of MicroPython. So what happened here? Like, is it, is MicroPython going in another direction? Did they just make this because Adafruit, hardware, etc.?
2 reasons that I'm aware of. I wasn't around when it started. It just sort of swept me up on the way. Two main reasons. One is MicroPython didn't support the chips that they were going to use. It supported the SMT line of ARM microcontrollers. Whereas Adafruit went with the Atmel, the microchip Atmel, the SAMD ones. The other reason was MicroPython is more aimed at professional developers, right? Like it's not as easy to use. You got to know a bit more about the tooling and so forth. There's a lot of stuff in there for like industrial process control and whatnot. Whereas Adafruit is all about newcomers, beginners, kids, learning, so they want something simpler and easier to use. So, yeah.
Could you give out pointers on optimizing code for MicroPython or CircuitPython beyond the use of minifying? Because those boards are small.
Those boards are still small. Actually, funny you should asked that, I have a guide and review on adding modules to CircuitPython, writing them in C. So they go right into the runtime. In Flash, don't take up any RAM. You can precompile. So it's a bytecode virtual machine. You can precompile so that instead of loading in the Pi files, which take space to process and parse and whatnot, you're directly loading in bytecode files, so they just drop in. They're still taking up RAM. The next level, and all the built-in libraries are available as MPY, the compiled Python files. The next step would be to freeze, make a custom build of the machine, and freezing those precompiled modules, which means they're in Flash and they get run from Flash. They don't go into RAM. And then the final step is just writing your module in C and hooking it up deep into the runtime, which isn't that hard. I've got coming out probably within a week or two on how to do that.
Now that you've started writing your code in CircuitPython, would you ever go back to C++ or C?
Yeah. Oh, I love C. I love C. C++ is a bit of an abomination. But yeah, depending on whether interface to the hardware is available in CircuitPython, whether I need high performance, in which case, and I don't want to try and put it into the machine, I can just write in C++. I'm working on a project now that's all in C++ because I'm working with an existing code base and extending it to run on our hardware and do some stuff. So it's always going to be a mix when you're working at this level. That's sort of the progression. MicroPython is a great entry into playing with hardware, right? Because it's easy to use in this context, but eventually you're probably going to run into a use case where you need to dip down into C. It's just the nature of the environment.
Do you have any pointers on how to package all of this in a format for either introducing to a classroom, like a primary classroom, or even to individual children at home? Like, how would you explore this with those communities?
Yeah, there's someone here that does that. And Adafruit does do a lot of that. I mean, the Circuit Playground Express is aimed at classrooms. You can buy class packs, packs of 10 for classrooms, get educational discounts and all of that.
But in terms of projects to motivate those, right? You can't just walk in a classroom with 10 of these boards, right?
Right.
How do you get the kids excited about it and introduce the concepts to them?
That is beyond what I do. But yeah, there are people that do that. There are a lot of introductory guides that you could base curriculum on, like especially with the Cricut, that robotics board. It's really neat. It's like, okay, let's hook up a servo with a bubble blowing arm, and let's hook a fan to the motor output, and now we have a robot that blows bubbles. And there's code driving all that, right? So it's quite amenable to that sort of thing.
Just to build on what Eric was asking, are there any simulators for the boards? So if you wanted to do a lot of debugging or different inputs?
For CircuitPython, no.
CircuitPython, MicroPython, any of the micro
No,
boards?
not that I'm aware of. That's
Okay.
one of the limitations that especially CircuitPython's not for professional development, really, although I would argue that. So you don't have debug capabilities so much. Now, with the Raspberry Pi compatibility stuff, you can develop your code on a Pi, depending on what you're doing, of course, right? There's going to be hardware level compatibility issues. You can develop a lot of your code anyway on the Pi in Python 3 with PyTest or whatever and do that. And then move it over to something smaller.
But how do you simulate the hardware layer?
Good question. One caveat. My background, does anyone here know TDD? Anyone do TDD? RSpec? You've heard of that. PySpec probably is a branch from that. I'm the guy behind RSpec, so I wrote a book on TDD, but with the hardware stuff, I don't bother. I push the button, the light. Oh, sorry. I push the button, the light comes on, it works. Right? I will be exploring as I'm doing some more advanced stuff. I'll be exploring some of that, especially with the Raspberry Pi. So that's sort of an open question right now.
So you can use PyCharm to debug real time for the if you use Raspberry Pi.
How about garbage collection? How does that work? Does it work?
It works. It works reasonably well. I haven't explored the garbage collector too much. It looks fairly traditional, mark sweep. I've never run into an issue with the garbage collector once my code fits. Let's just say that. If I've ever had allocation issues, it's because the code's too big and I hit the RAM ceiling trying to load in stuff. But yeah, once it fits and it's running, I haven't run into any GC memory issues. So.
We have time for maybe 2 more questions if anyone has more questions. Okay, cool. Let's thank Dave for his time.